Hi everyone, today I'll be going through improper integration. Okay, okay, Actually, improper integration is an extension of your definite integral. Okay, so how does it? Uh, what's the difference? Correct. What's the difference between definite integral and improper integral? So, as this is the conditions. So this is your condition for your definite integral that is the interval of integration will be finite, okay, and bounded. Now, so we could extend our definite integral integrate from a to b fx dx to include infinite interval, okay, infinite interval. So what is the meaning of infinite interval? Means, for example, so that means we have our interval could be from negative infinity to b, okay, or could be from b a to positive infinity, or we can have from negative infinity to positive infinity. Okay, so how does it, what are the difference? So for example, we can draw a graph that shows this property. Let's say from here is b and here is your, okay, sorry, it's not correct, it's the other way. So let's say here is negative infinity and here is b. Okay, so when you are doing this, finding the integral, definite integral of infinite interval, we are actually doing the improper integration. So the improper integration will look like that: integrate from negative infinity to b fx dx. Okay, so normally we don't involve our limits to have negative or positive infinity. Okay, so in this chapter will involve our upper limit, which is a or b, that can include infinity values. So in this way we introduce the idea of limit. So how? So we write a limit a approaches to negative infinity, then integrate a to b fx dx. Okay, now suppose we come back to our question. So suppose we integrate fx without the limits, will give us f capital X plus c. Okay, suppose we have this notation for, okay, so we will be using this. Okay, to simplify our improper integration. Okay, so how? So we come back to the working again. So we have square bracket fx. Of course, we have to limit capital Fx. Again, we put b a. Okay, as what we do for our definite integral. So now equals to. So you put the upper limit minus the lower limit. The upper endpoint minus the lower endpoint. So get f okay. So next time, okay, I recommend if you see this integration, first you find your indefinite integral, which is your capital Fx. Then you use this formula. Or this one, okay. So you write this into your cheat sheet. That means this is equals to the last working. So next, for this part, we may have this. A maybe is here. Now, towards the right, of course, is your positive infinity. Right. Towards the right. So integrate a to infinity fx dx. Okay, so then we say equal. Again, we use the limit idea. B approaches to infinity. Then integrate a to b fx dx. Then equals to limit. So now you use your capital F, capital Fx. So capital Fx. Same thing, you put b on top and a below. Now the next step will be limit b approaches to infinity fb. Okay, it's much better if you bracket the fb minus fa. That means the limit only involve b. So similarly, in this one you memorize as this is equals to this. So you can write this as a formula in your cheat sheet. Okay, lastly, we have negative infinity to infinity. So something like that, negative infinity to infinity. So of course this is your x-axis. So how do we do our integration? So our integration will be negative infinity to infinity x dx. But how we split the limit? So we can think of having a c in between negative infinity to infinity. So something like that. So anywhere. So c. So you integrate from negative infinity to c. Then plus c to infinity. Okay. So now we introduce our limit. So limit a approaches to minus infinity, integrate a c fx dx plus limit b approaches to infinity, integrate c to b fx dx. So now you replace your integration with the capital F fx, c on top, a below, plus limit b approaches to infinity, capital Fx, b and c. Okay, so you simplify, so you have fc minus limit a approaches to negative infinity, square bracket fa, then plus fb plus limit b approaches to infinity, square bracket fb minus fc. So you will see these two are equal, right? So finally your negative infinity to infinity end up with this limit b approaches to infinity, square bracket fb minus limit a approaches to negative infinity, square bracket f a. Okay, so you can memorize this, which give you this result. Okay, so I advise you to use this formula, and you can write all this down in your cheat sheet. Okay, so this, for the first part of the improper integral video, I will explain about infinite interval. Okay, now there's another condition that give you another types of situation that will give you improper integration, or what, or unbounded. Okay, who is unbounded? Fx is unbounded, or fx is unbounded. So unbounded means, okay, in simplicity, unbounded means there is an asymptote that exists. At least a vertical asymptote. Okay, at x equals to a or x equals to p. That means imply the graph is discontinuous. So you can understand that if fx is discontinuous, that means fx is unbounded. So that means there is a vertical asymptote. So for the first part, the second part of the video, I will explain part 2. We'll go through this part. So this one will be part 2. That means part 2, next video. Okay, next video I will be going through this. So first I will go into infinite interval. Okay, so let's go to the first example of infinite interval for improper integration. Okay, now before we go to the example, I would like to stress that to find all these limits that involve infinity, okay, so you remember all these limits may need to use L'Hopital rules. So L'Hopital rule may be involved. Okay, so most likely will be involved. Okay, only for simple cases, L'Hopital rule will not be involved. So L'Hopital rule may be used. So just keep in mind, when you are doing this type of question, you may need to use your L'Hopital rule. Okay, so that is one thing you have to know. Now the next thing I want to mention is, okay, sometimes the limit does not exist, right? Remember? So if the limit exists, okay, so okay, then we say that the improper integral is convergent. Okay, now if the limit does not exist, so does not exist means infinity. So this means does not exist, limit does not exist means infinity. Okay, so if it does not exist or we don't know the value, can be or undetermined or changing value, the limit keep on changing, the limit keep on changing, so it's also under limit does not exist. Okay. So if that's the case, so the improper integral is divergent. Okay. So only two types: convergent, limit exists, means convergent, limit does not exist means divergent. Okay, so now we are ready for the first example. Okay, this is the first example on your slide. So first step, I integrate without limits. So you get minus e minus x plus c. Okay, so now you put in the limits. So therefore, so this is your capital Fx, right? And this is your small fx. So e minus x dx. So straight away you can put your limit b approaches to infinity, b on top and minus 1b. Right. Now if you take away the negative sign, okay, so you can return as like that. So you just swap the limits. Okay, so if you take away the negative sign, you have to swap the limits. So this one, take away negative sign, you swap the limits. That's one way of doing. that equals to e minus 1 minus e minus 1 minus limit b approaches to infinity e minus b, and you get e minus limit one over eb. Okay, of course this will give you 1 over infinity, right, which is 0, right? So ultimately the answer is E. So that is how you can do this type of improper integration. So now we can go to the next example. Okay, 3b. So similarly, I just integrate without the limits. Okay, so now you substitute your limits in. So limit b approaches to infinity sine x b 0, so it becomes sine limit sine b minus sine 0, so you get limit b approaches to infinity sine b. Now as you can see, the sine curve is actually going on. This is your sine curve. So where's the infinity? We don't know. So that means the limit is may not be stabilized to a single value. So this way we say this is divergent, because the limit does not stabilize to a single value, right? So this is divergent. So therefore we say since sine b does not exist, divergent also means does not exist. The limit does not exist. Okay, so 0 infinity x dx is divergent. Okay, so you go to the next example in your slide. Okay, this is the last example for infinite interval in your slide. So okay, so first, same thing, you integrate without the limits. So this you have to use by parts. So you integrate ex, and then you differentiate x. Okay, so now next you introduce the limits now. So when you introduce a limit, you no need to put a c. So we put in your a 0, e0 minus e0, so up then minus limit okay. So this one will give you minus 1 minus limit plus limit now obviously this one you can see is actually 1 over e infinity. Of course will become 1 over infinity, it will become 0, right? So straight away write minus 1. Now for this one will be interesting because this one minus infinity, then e to power minus infinity. Now e to power minus infinity is actually minus infinity over infinity. Now this side will become 0, right? So I better rewrite again. So this one minus infinity times 1 over e infinity. So minus infinity times 0. Okay, so that means you have to, you can use L'Hopital, right? So minus 1 minus limit. Now you have to change, huh? So I presume changing the e exponential will be easier. Change to a fraction. So now we have a fx over gx. Get ready for your L'Hopital rule. So plus, of course, plus 0, right? So now how? Now we differentiate. So limit a prime over e minus a prime. Now a prime is 1. Over minus e minus a again, right? So minus minus will give you plus. So it will become this. So of course this one you already know is 1 over zero, same as before. So finally the answer equals to minus 1. Okay, so that's the final answer for this question. Okay, so I hope now you understand how to do improper integration with infinite interval limits. Okay, so the next video I will be showing how to do improper integration that involve unbounded fx. That means there's a vertical asymptote involved. Okay, thank you very much for your attention.